Assalamu alaikum wa rahmatullahi wa barakatuh. In this record, we will explain Kirchhoff's rules. If you want to get the sum of current at any point in the circuit, specifically in complex circuits, we are going to use Kirchhoff rules. So what is the Kirchhoff rules? Kirchhoff rules are divided into two rules. The first is junction rule. Like at any junction, the sum of the current must equal zero. Sum of I will equal zero. The amount of charge flowing out the branch on right must equal the amount flowing into the single branch on the left as shown in this photo. Applying this rule to the junction, I1 minus I2 minus I3 will equal 0. The first rule is the loop rule. The sum of the potential difference across all elements around any closed circuit loop must be 0. Sum of delta V will equal 0. So, in each diagram, V will equal VB minus VA, and the second element is transferred from A to B, left to right. Like in number A, charges move from the high potential end of resistor towards the low potential end. So if resistor is traversed in the direction of the current, the potential difference delta V will equal minus IR. In number B, if a resistor is traversed in the direction opposite the current, the potential difference will equal plus IR. In number C, if a source of EMF assumed to have zero internal resistance is traversed in the direction of the EMF from negative to positive, the potential difference will equal positive epsilon. This is EMF. In number D, if a source of EMF assumed to have zero internal resistance is traversed in the direction opposite the EMF from positive to negative, the potential difference will equal minus epsilon. In this question, a single loop circuit contains two resistors and two batteries. Neglect the internal resistance of the battery. The batteries find the current in the circuit. Okay, so there are no junction in the single loop circuit. Therefore, the current is the same in all elements. And applying Kirchhoff's loop rules to the single loop in the circuit, the summation of delta V will equal 0, which will equal E1 minus IR1 minus E2 minus IR2 will equal 0. So the current will equal E1 minus I2 over R1 plus R2 will equal 6.0 minus 12 over 2.0 plus 10, which will equal negative 0.33 ampere.